का वो तो नहीं मांगेगा.
Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session on virtual labs. Well, today we have taken up this wonderful topic, which is refraction of light in rectangular glass slab. We are going to have a simulation on the same, and this topic belongs to class 10 students, specifically physics. And I must tell you that right now you are watching us on PM eVidya channels 6 to 12 and also on our YouTube handle NCERT official. As you all know, session is live and interactive as always. So in the middle of the session, if you have any doubt, even while performing the simulation or demonstration, you can definitely ask our expert about it. So please take down our phone number, which is 880044 0559. We also have a dedicated email ID for you, that is diksha.training at CIET.nic.in. And lastly, since we are streaming live on our YouTube handle NCERT official, please feel free to get in touch with us through WhatsApp, of course, and of course through NCERT official. Plus, do let us know what all doubts you have, what all suggestions you would like to give. That is extremely important. Now, there is one more thing that I would like to tell you, that virtual labs, we have been learning about the same in the previous many sessions. We can learn so many subjects through virtual labs, but you know what, when it comes to physics, especially the learning of sciences, virtual lab plays a very important role because it gives us a controlled environment where we can perform demonstrations or simulations without having any risk. And to be precise, virtual lab on physics, we can say it's an online platform that allows students to conduct experiments and investigations in a simulated and controlled environment. The best part is it enhances participation, it enhances engagement, there is gamification of concepts, and it provides ample material for our diverse learners, because we have learners with diverse learning styles. We talk about inclusivity, so that is the best part of virtual lab. And even if there is a dearth of resources, you can use virtual lab. It's so cost effective. All you need is a stable internet connection and an IoT device to go and perform the experiments n number of times. So today, since we have taken up this very interesting topic, which is refraction of light in rectangular glass slab, how are we going to demonstrate it through virtual lab, and what exactly refraction of light means? Let me ask all these questions to our expert. So please join me in welcoming Dr. Uma D. Sharma. Ma'am is academic consultant from CIET NCERT, New Delhi. Ma'am, namaskar and very warm welcome to the session.
Yeah.
Now, ma'am, we have understood what virtual labs are. We also know they are not replacements of real physical laboratories, but it's kind of an add-on, which is like icing on the cake.
Absolutely.
We have already studied about reflection in the previous sessions. Today, we are focusing on refraction. Now, before you go on for simulations, I want you to please explain us the difference between the two and what exactly are we going to cover in today's session.
Sure, ma'am. See, we have already studied in our previous session about the reflection of light, and both reflection of light as well as refraction of light, both are very fundamental concept in optics and which exhibit the wave phenomena of light. So, in reflection of light, whenever light travels and reflect back to the same medium, suppose from air to air, so just like in the case of mirror, so that is called reflection of light. But refraction of light is another concept where light travels from one medium to another medium. It just passes from one medium to another medium, another transparent medium, for example air to glass, and in this case its speeds changes. So that is a refraction of light, and which is a very important concept, and today we will learn more about it and do the simulation for the same.
Absolutely, ma'am. And ma'am, one more thing I want to ask. Physics is one subject which is very difficult for many people, and that is why they skip opting it for higher studies. How do you think that we can have the concept clarity as far as physics is concerned through virtual labs?
Sure,
can we learn it effectively?
Yes, definitely. See, in virtual labs gives us a opportunity to do in a more interactive way, and it gives a experiential learning case here. The student can actually do that thing by their applying the different media. They can understand it more immersively in using virtual labs.
Right, ma'am. So I have so many questions which of course you will be telling through demonstration, because I want to know how we can do the self-assessment, whether there are references available, what kind of aid is there through virtual labs. So now I request you to kindly perform the demonstration for all of us.
Sure, ma'am.
And one more question before you start. Do we really need to sign up before the demonstration?
Yes, definitely we need to sign it before we start it. Because see it one time this sign up is required over here, and once you sign it, it records that you have entered that diksha.government.in and you have applied over here. I will show it over here how to do it.
So this is the page from where we need to access the virtual labs,
diksha.gov.in. Once you enroll over here, see, so here different focus areas of Dikshas are there. You can just go to the virtual lab part 1. Virtual lab part, see, you can see it over here, a virtual lab. Once you click it over here, you will get all the simulation from grade 6 to grade 12 in both English and Hindi medium. And today I have chosen this for grade 10th because right now they might be studying this light chapter in their schools. So this will be very helpful for them. And last time, that's why we have learned about reflection. Today we will start with the refraction of light. Now see, once we just goes to the science, and as soon as I opened it, it shows the welcome to Diksha login page will open. So the learner can, what they can do, they can just apply, put their this Gmail ID over here and the password. Since I have already logged in, I will use sign in with Google. Both the case are there. You can write it here also.
This is for the first time users.
Yes, first time. And also you can go from here, sign in with the Google.
Alright.
So I have already signed it with Google. So I will sign in with Google over here and see the different accounts are there. So whatever account you choose, which you have enrolled, sign it before, you will just continue. Put the continue, and it will redirect to the sign in to the Diksha plot here. Now we have entered to the this virtual lab page. Science lab for this. We have entered this page. So this is a very simple step. They have to follow this step, and once you entered over here, this is a chapter. This one 40th.
So this is the table of contents.
Mirror. Yes, table of content is there. And here the measure of angle of refraction, because we are studying the refraction part, this 40th experiment is there. So experiment 40, it will redirect to it. Here the theory is there. This experiment gives about the theory, the same theory which is there for like exactly the same thing which is there in the lab manual. Material required is there, rectangular slab. Normally we do this with the rectangular glass slab. So the entire theory is available over here. You can see the observation table is there. The same observation table we have provided in the simulation case, and there the student can do it.
So we can do the theory part as well.
So I will directly go to this to study the refraction of light in the rectangular glass slab, which I want to demonstrate right now. So here you will just see this. This is a link over here, refraction of light in the rectangular glass slab. You will click on it. Once you click it, it will redirect to this page to study the refraction of light in the rectangular glass slab. So here the entire, see, one theory is already available, that is only the sheet which is as per the NCERT syllabus. This is also as per the NCERT. The student can go through this theory part objective, because what we are doing, we are tracing the path of a ray of light passing through a rectangular glass slab for different angle of incidence and for the angle of refraction, and find out the angle of refraction and just see how much the light will deviate. And here also what we are doing, we are applying the law of refraction and just see that whether it is okay for this refraction or not. So what is the exactly refraction of light is? It's simply the bending of light from when it travels from one medium to another medium. See, so why this bending happens, why it changes its direction. So the basic thing is that it's the velocity of light changes. So whenever it travels from the rarer medium to denser medium, its velocity decreases, and when it travels from denser to rarer medium, its velocity increases. Normally the maximum velocity of light is we take it for the vacuum, which is 3 into 10 to power 8 meter per second. So whenever it travels from air to glass medium, obviously its velocity decreases and hence its direction changes. So here we just do this by the simulation and understand this refraction process in more detail. Ma'am. So you will see that over here the same the picture diagram of that experimental setup is there. This is the angle of incidence is there, refraction is there, okay. The theory is written over there, and this is angle of incidence, angle of refraction, and the Snell's law, which is the law of refraction, which simply states that gives a relationship between the angle of incidence to the angle of refraction is all, their ratio is always constant, right.
Okay.
So, in detail there is another experiment. We will talk about this refractive index part in the next experiment. Here I am just explaining about the refraction of light. Now, here you will see one table is also mentioned over here. This table gives the idea of different medium, in different medium how the refractive index is there, different refractive index are there, and because based on it, it bends. More dense the medium, more bending will be there of light, okay. So, basic rule is there, whenever light travels from rarer to denser medium, it moves towards the normal. Normal is the, we are talking about the interface between two media, okay. So, when it air to, we are talking about air to glass. So, in that case, the media, the pair of media is air to glass, and the interface is the boundary between the two media, right, and normal is perpendicular line across that interface. So, it bends towards the normal in this case, and when the light travels from denser to rarer medium, it bends away from the normal, because only because of velocity changes, right. I explained before also, when it travels to denser medium, its velocity decreases, so it bends towards the normal, and here its velocity increases, so it bends away from the normal. So, this is the basic explanation of the refraction of light, and this everyone has might experience this thing. When the pencil we put straight in it, you will not observe this refraction part, because here the angle of incidence is 0. So, angle, because it is a normal, here light travels in the straight path, but when it is taking some angle along the interface, then only there is some bending is there, okay. So, this we will demonstrate in the simulation part.
Okay.
So, this is a theory thing. So, here the procedure is already there, animation part is also there, the learner can see the entire animated version of the same experiment.
Procedure is like how you are going to perform the experiment?
Yes, that is more for the like when we are doing in the practical labs, because take the sheet of the paper and everything, it is explained over there, okay. And the, because procedure in that way, and the animation part tells about how to do this experiment entirely. So, directly we are going to the simulation part and we will do this. So, you will see that this kind of page will open, okay. This is a top view. When the students are doing in their lab, exactly the same view they are experiencing. This is a rectangular glass lab, okay, and when we place a needle to observe, because when the light is like reflected through the pins, okay, that light, and then they observe the refracted part towards the other end from the SR interface over here. So, you will observe this kind of this kind of light is refracted from air to glass medium and then glass to air medium. So, I will here the different, you can see the different options are available, show normals and angles. I will put it over here, normal, okay, because here two interface are there, one from air to glass, so one normal and N1 over here, and here glass to air, so again N2 here, okay. And in the first interface, it is from air to glass, that means rarer medium to denser medium, so it bends towards the normal, and the second interface, it is light traveling from glass to air. So, what happens over here? It moves away from the normal, light is refracted away from the normal, right. Now, I will one more point is there, show lateral displacement. So, you will see a dotted line over here. This dotted line represents that if there is no refraction is there, if I remove that glass slab, the light will travel in a straight path, because we know that light travels in a straight path, okay, until and unless some medium is present over there, right. Then show labels also, because student want to know what are they, okay. So, so I will put this thing also, show labels. Here it explain about which medium it is. The medium is air, its refractive index is 1, because velocity is maximum over here. Here this is a crown glass, rectangular glass slab is there, whose refractive index is 1.52, okay, because, and obviously it is more, its refractive index is more than the air, so it is a denser medium. So, now we will do this experiment. So, we can vary the different angle of incidence, you can see over there, see one, okay. So, one by one what we are doing, for varying angle of incidence, we will measure the angle of refraction, okay. So, first I have taken angle of incidence as 38 degree. So, the beauty of this experiment is there, here the same you will see the observation table is also there.
Yeah.
So, I will write the angle of incidence which is 38 degree, 38 degree. Then angle of refraction, we can again see it from here, angle of refraction is again 38, you can see this angle of refraction is how much, 24.2, this is the angle of refraction.
Okay.
Angle of refraction is 24.2. And what is the angle of emergence? Angle of emergence is this much, the ray which emerged from the rectangular glass slab, this angle E, and its value is given here 38, because angle of incidence is always equals to angle of emergence. Why? Reason is because medium is same, here also air medium, outer is also air incident, at the incident level also air medium. So, angle is same. So, I minus E, it comes out to be, when I take a difference it comes out to be 0. And what is the displacement? Displacement, because since I have taken a rectangular glass slab of certain width, so its rectangle, this displacement is, this is parallel line, so it is 5.22, 5.22. So, what is the interpretation over here? The interpretation is this, again we can take one more reading, okay, then I will explain about the interpretation part. One more reading, take, you can change this 57 degree, 57 degree angle of incidence, again we can say the angle of refraction is 33.99, and then emergence is how much, again 57. So, here also no deviation is there, the difference between angle of incidence and emergences comes out to be 0 only. Okay, that means the light travels in a straight line, it simply refracted to glass medium, and then from glass to air medium with the same angle, no other deviation is there. So, this proves the refraction of light law. Okay. One more thing is there, in virtual lab, because normally in practical lab we are doing this experiment in the top view case. Okay. So, suppose we want to see the side view. So, here one more feature is available which is a side view. We can see what exactly, how the light is refracted and how it is deviated when we are seeing from the side of the rectangular glass slab. Now, this is the emergent ray, this is a show value, I can, okay, show value 1.52 and refractive index 1 point this thing. Now, you can see you can see how this angle of incidence changes and how light is coming back, and when you take extend this light, this incoming ray light, you will observe that this is a straight line, this will comes out to be straight line. So, this is a more beautiful way of the side view. Okay. And again one more thing is here, instruction is already written over here. So, in this way we can verify the law of refraction over here, it comes out to be constant. Here we are exactly simply saying how the light is refracted, and when they comes to the same medium, what will its angle of emergence. So, it comes out to be equal only, angle E, that is emergent angle and incident angles comes out to be equal in the case of a rectangular glass slab, which tells about how the light rays bend and then come back to the original position in this case. Okay.
Right. Now, because I remember when you tried to perform this experiment in real physical laboratories, like when we were supposed to do that, you know, when you were in class 9 or 10, of course, there was dearth of time, there was dearth of resources, there was only one glass slab and we had to be extra careful. So, it should not be, you know, breaking up, and of course, you know, every student is getting a chance to perform the experiment. And I think here you get the time, you get the space, and there is no need to hurry also.
Yes,
you can view it differently, you can record your observations nicely, and if you still don't get it, you can always go back to the previous classes, you can perform those demonstrations, get your basics right, and then come again.
Yes, definitely, definitely ma'am. And here it is a time taking experiment, because what happens, they do with the needle, that all pin.
Yes,
okay, they had to insert that all pin
and
through
then
a
glass
wooden
strips
back.
also.
Yes, glass, and then they have to view that the straight line, the path of they have to trace the path of the light, which is a straight line. Okay. So, in this case we can simply observe those these pins and see the how they in the output how the light is coming outward in a straight line. Okay. Now, apart from that, after doing that simulation thing, they can go for this self evaluation part, which
like
is
how much they have understood the
this concept or not.
Now they can take the assessment. Okay.
Yes, exactly. So, see the ray of light incident on one of the parallel face of the rectangular glass slab emerges out of the opposite parallel face. Yes, it is along the same straight line as the incident ray or parallel to the incident and laterally displaced, because it is, we have seen over here the parallel to the incident ray, but laterally displaced because there is some thickness of the glass slab is there. Okay. So, same different diagrams are mentioned given over here. So, we have to choose the path of the ray diagram over here. So, which one is correct, the tracing of the this thing. So, we have to see which one is correct. So, I am randomly putting this one.
Okay.
Why does the bending of light takes place? I told you because of different velocity, because when the medium change, the velocity changes. Okay. And in which the direction does the ray bend when it travels from denser medium to rarer medium? So, it bends from normal. I have explained this thing, denser to rarer, it moves away from the normal, bends away from the normal as it meets the surface of the rarer, because bending takes place always at the interface level, not inside or outside of the medium.
Right.
Refractive index is a property of that particular medium for a pair of medium, okay, not one media, because refractive index is a ratio of this velocity from that vacuum to the medium. If I define refractive index is simply, we can say, the optical density, which tells about the ratio of the light which travels from vacuum to medium. So, it is defined as the Greek letter mu, which is equals to c upon v, where c is normally the velocity of light in a vacuum medium and v is the velocity of light in medium. So, this ratio is always constant for a particular pair of media. If we change the media, so obviously refractive index will get changed. Now, does the refractive index of substance changes with the color of light? No, refractive index does not. Yes, refractive index depends, because wavelength is there, wavelength depends on the velocity. So, yes, refractive index will change. Okay. Now, give the example of total internal reflection. These are other things looming, both of these we can say that. So, randomly I am just putting right now all these questions. Okay, all these questions we will and submit. So,
will I get the results? Okay, I have got the results also.
So, suppose I have put the wrong, this intentionally wrong these questions. So, you will see that. Okay. So,
and what's the reason that I am getting, that why it's correct and why it's incorrect? Correct, okay, I know. But what about the wrong things that I've chosen?
So, they can go again to understand the theory part, okay? And here it is get absorbed by the, some questions may be wrong, that this one parallel to the incident ray, but laterally displaced. Okay, so they can go again back to the theory part and understand where they are wrong. Okay, for this references are given. You can see this references part. The Snell's law, click here to watch the entire Snell's law is here. About the Snell's law, read here. So, as I open that read here, so it redirect to the Snell's law page, where the whole in a detailed form Wikipedia gives you the this
so
detailed information about their
additional learning
material is there. Yes, additional materials is there. Again, if they want to understand more about the application of total internal reflection or what is mirage and looming, again they can go to click here to read. It will redirect to the that page, Wikipedia page, where they will in a detailed way they can learn about
it. And is it always Wikipedia, or you would also get some kind of books, reference for the books by different authors that you can actually learn and practice
yes,
from?
Yes, different books are available. They can go for HC Verma also, NCERT is there. Okay, and here they have shared this content from which is Wikipedia only. So, in a detailed form, like it is very detailed one, it is not appropriate for the class 10th, but basic they can understand from here, and some simple books from NCERT they can see. So, from there you can easily get it.
Now, since we have performed the demonstration, we have also done the self-assessment. What if we want to give our feedback? Is there any option that we can submit a feedback, what exactly we liked and what are the things that can be improved in this scenario?
See, one more feature is there. This is a feedback. Here the email of the user is there, department, class detail, class 10th, Name of the experiment already it is mentioned over here, to study the refraction of light in the rectangular glass slab. Type of experiment, simulator. So whether they want to change some change, okay, they can put this mark over here where it is very good, or they want some changes over here to average, they can give their choice of feedback over here against this statement. Okay. And how helpful do you feel? They can write 2 lines or 3 lines, whatever they feel about the experiment. Did you experience any problem? So they can mention that the same experience about good or bad.
Great.
And is there anything you would like to tell us? So these are the different the various feedback is there. So in a detailed form they can submit it and it will be recorded in the system.
Well, that is lovely, because you not only perform experiments here, you also record your observations, you get different views also, you get reference material, and you get the much needed help, which is right there in terms of tutorials. And now it's time for me to wrap up today's session. But of course, before I close, I would like ma'am to give us closing remarks. Ma'am, you have performed these experiments, you have been doing that previously also. What do you think is the message for all those who probably want to brush up their skills in physics, or want to make it easier for them?
Yes, they can definitely go to this virtual lab for doing the, before going to the experimental lab, okay, in their school. And it can give them a very quickly the simulation part, quickly they can go for the this video of the entire experiment. So the entire thing will be brushed up in a few seconds, and entire resources are available over here. So they can definitely go to this virtual lab through Diksha.
This is a classic example of blended learning, and not just for students but for teachers also. It is very,
very
easy to make students understand about these concepts that are quite abstract in nature at times. Right. So Dr. Uma, thank you so much for your contribution and your time for the session. Well, viewers, now we are winding up the session over here, but let me tell you what exactly we learned. We learned demonstration of simulation on refraction of light in rectangular glass slab. It was our virtual lab session specifically meant for class 10 students, and the subject was physics. Now, let's close the session here, but before I leave, there are a few more important informations for all of you out there. Let's start with textbooks. Textbooks for grade 4 and 7 are now available on Amazon, Flipkart and NCERT website. Please go and purchase them from there and take a quick look at the schedule, what's all coming ahead. So we have the schedule, we are through with the session on virtual labs, and in a short while from now, you can watch our session on teaching learning interventions for inclusive classrooms at 12 p.m. where we will study statistics under mathematics. And 2 p.m. is the time for our session in Sanskrit, followed by a session of social sciences at 2:30. Topic will be understanding markets. 3 p.m. we will bring you a session of science, and we will learn about reproduction in animals, followed by a session of mathematics at 3:30, and the topic will be squares and square roots part 4. 4 to 5 p.m. is the time for our online training program, and this week we are learning about micro learning and nano courses. We will end the day with our session Sahyog, where we will talk about digital well-being, smart use of screen time. With this, it's a wrap. This is me, Harpreet Kaur, taking leave of you, and will join you soon. Namaskar.